let's go ahead and do another one of those. So we've got for number 8, which I didn't have a lot of space. There we go. I need to find the same things. So measure of angle 1, measure of angle 2, the measure of angle 3, measure of angle 4, and then also just measure of angle 6. So we don't have as many. And notice it skips 5. It's because this 80 degrees right here is our 5. So this one's a little tougher just because it cuts off this line. So what I suggest doing is extending that line out so it's a little easier to see what's going on. So even though right here is not marked, this angle and 80 degrees, those are going to be the same. They are the same size, the same slice of pie, right? So I know that's 80 degrees as well right here. Now if that's 80 degrees, 4 and that angle I just highlighted are alternate interior angles, so they're congruent. And so is this angle right here, this vertical angle at 1. So all of those that I just highlighted are all going to be congruent. So they're all going to be 80 degrees. So 80 degrees for 1, 80 degrees for 4. Then what I'm going to do is I'm going to look right here. This is a linear pair between 6 and that original 80 degrees. So they have to add up to 180. So I subtract 80 degrees from 180, and I get 100 degrees for 6. So that's 100 degrees right here, which that has to correlate with the 3 because they're alternate interior angles, and the 2 because 6 and 2 are corresponding, or you can just say 3 and 2 are vertical. So all those are 100 degrees, and we are done. So let's make it a little more exciting. So sometimes you'll have problems like this where they'll just have 2 angles right here. And remember, either they are congruent, so they're equal, or they are going to be supplementary, meaning they are going to add up to 180. And honestly, if you just look at the angle, since these are parallel lines, if it looks like they're the same size, like it'd be the same slice of pie, then you can just go ahead and say they're equal. So if you look at how wide both of these are right here, they're both the same width. These are corresponding angles, which means they are congruent. So I'm just going to go ahead and set them equal to each other. The nice thing about geometry is you can visually kind of guess what's going to happen on that problem. And it usually is right. So I'm going to go ahead and solve this. So I subtract 2x. So I get 56 equals 5x plus 1. Then I'll subtract the 1. So 55 equals 5x. And then divide both sides by 5. And you end up with x is equal to 11. And that's all you have to do because it just says find the value of x. So let's go to 10. Let's see, does this one look like it's congruent? So 6x minus 7 is this one right here. Does that look like it's the same as this one? Notice, no, this one's smaller. I have like a little smaller arc than this one. That one's a little wider, right? So they are different sizes, which means that tells us that they actually add up to 180. So I don't know if you noticed, but I took that 2x plus 1, so this right here. I added it to the 6x minus 77, and I made sure they added up to 180 so we can then solve this. So first thing you're going to do is combine like terms. So 6x plus 2x is 8x. And then a negative 77 plus 1 is negative 76. Then I'll go ahead and add 76 to both sides. Oops. Let's make that black. There we go. So you have 8x. There we go. Equals 180 plus 76 is 256. And then I'll divide both sides by 5. And let's figure, or not by 5, sorry, having a moment right now. By 8, see, even the math teacher has moments. So divide both sides by 8, and 256 divided by 8 is 32. you end up with x equals 32, and that is your answer.